all those things. Here. To the moon. Wall Street bets. Okay. So, where did we leave off? I'm opening the 159. Oh, okay. So, we were at... Okay, let me change my view to writing mode. Okay. Where did it go? It's like gone. Oh, there we go. Boom. Okay. So we left off last time talking about the properties of the distribution. So let's just scroll up a little. Properties of a distribution for a numerical variable. So hopefully you guys remember that there are four things: the shape, the outliers, what the center is, and what the spread is. So, does anyone remember the different shapes? What sort of shapes did we deal with? Give me some examples. And I invite you to turn on your camera if you want to. Join us. Okay, yeah, the uniform distribution. What makes it look uniform? That's a good question. So what makes a uniform distribution look uniform? Yes, that's a pretty good way to describe it. The mode would be that high point, right? The uniform distribution looks sort of flat. There's no obvious mode, right? Like what you described as there's no uphill and downhill. If you have a high point, the mode, you have to go up to it and then down to it. Okay, good. What other sorts of shapes do we have for the distribution? We've got uniform. What else we got? Skewed. What does it mean to be skewed? Yes, so the proper terminology to use here is the tails, right? So if you look at this histogram right here, you can see that I have my mode, the center. I measure from the center all the way out to the right for the right tail. I measure up to the left for the left tail. The right tail is longer, so it's skewed, right skewed. Okay. And I think we talked about this one, right skewed. Okay, let's talk about another one. Last one. What makes you symmetric? Do you remember what makes you symmetric? Yeah, roughly the same length, yes. And what will there not be? Most likely. No outliers. Good, good, good. Cool. So we're going to continue with this today, and we're going to move on to the spread. So to let you know, the measures of center and spread, an outlier is like, let me scroll up a little. An outlier is where you have a small bin where there's a gap between that bin and everything else. So like if you look at this one, you can see I like highlighted it on the right, and then I wrote like empty, right? There's that gap between a little bin and everything else. So it's like literally apart and away from everyone. Bueno, bueno? Cool, awesome. Oops. Okay, so we've already learned one type of measure of center, and it's called the mean. And we're going to learn a measure of spread that's called standard deviation. And there are different types of center and spreads, but they come together in pairs. So just to let you know, there are other measures of center and spread that we will learn. Okay, so it's not like there's only mean and standard deviation, but they come together in pairs. So does it make sense if you talk about the mean as the center, then the spread has to be the standard deviation? So they come in pairs, i.e. mean is always paired with standard deviation as the spread. And there will be other pairs that we learn about. So for now, we're completing our first pair. We already learned about mean. Now we're going to talk about standard deviation. And I'll explain to you like what spread is. It's actually pretty straightforward. So remember that the mean is a measure of center, and the mean tells you what the typical sort of value is. So I think we asked everybody like how many siblings do you have? And we found out that the average number of siblings, or the mean number of siblings, was 2.5. So in other words, typically, people have 2.5 siblings. And then we talked about how that was a sort of weird way to talk about a number of siblings because it's impossible to have 2.5, right? But the whole idea is that the mean tells you what is normal or typical for the data you're looking at. Statistics, is, interestingly enough, is very racist, and I say that actually very seriously. The people who, there was a bunch of people, one of them, their name was Francis Galton. He came up with the bell curve, and he was a biologist. And statistics is really a study of trying to say what is normal. And I'll just be honest, like, the relationship between science and white supremacy has been very interesting because a lot of the science that we learn is rooted in like a Eurocentric viewpoint. And we have to acknowledge that historically, like, this was used to define what would be normal. And like, it's supposedly objective, but like for social issues, that doesn't work out sometimes. And you should probably remember that. Because like this has been used to justify all sorts of stuff in the past. And I highly recommend you read about it. Like go Google Francis Galton. He was a eugenicist. He said like we should get rid of people of particular races because what's typical for them is like lower or deficient compared to these other people. So the more you know, the more you can have a discussion about it with people who may not be aware of this. But anyways, it is very useful. It's also just sometimes been used to justify horrible shit. Like everything. Okay, so anyways, end rant. Let's talk about spread now. So, the mean tells you what's typical. The standard deviation tells you how far from typical do subjects usually get. Spread answers that question. And I'm going to draw a picture to explain this. But it's good to write down this sentence because when you ask yourself, like, wait, what the hell does spread mean? This is a very nice way to answer it. It tells you, well, the spread tells me how far from typical the subjects usually get. So we're going to make up an example here to explain, like, what the hell do I mean by that? Should I wait before I scroll down? Okay, cool. I don't want to wait too long and I don't want to wait too little, so I figured I'd ask. I'll just drink my tea. The standard deviation is a type of spread, but in general, spread tells you how far from typical subjects usually get. And there's different ways to talk about that. That's a good question, though. I wish I had like a green screen behind me so I could do the little thing where the box and it's just me there sort of like floating. Maybe someday I'll get one. For now, I think my streamer setup is pretty decent. I like it. Okay. So I'm going to scroll down a little. Okay, and I'm going to draw a fake histogram. I'm going to like make one. So there's our axis. Okay, our variable is going to be... So our variable will be number of shoes owned. Okay. So at the minimum, how many pairs of shoes can you own? Let's pairs of shoes, not like individual shoes. So 2 shoes is a pair of shoes. We'll count that as 1. So at a minimum, how many pairs of shoes can you own? Nope. Yeah, there we go. You can go all the way down to none. There are some people in the world who have no shoes. Okay, there's no real cap on the maximum, but I guess Imelda Marcos holds like the record there. We'll just say that, we'll put like 100 over her. Does everyone know who Imelda Marcos is? Where are my Filipinos? Oh, I'll let one person look up. She's a Filipino. She was the first lady of the Philippines in like the 1960s. She was famous for having like shitloads of shoes. Like lots. She also like had really good sense of style. You should look her up. So anyways. Yeah, she sounds familiar now. You're like, wait, I know, I've heard this lady. Okay, so let's have the bins go by 20. So 20, 40, 60, 80. Okay, so 100 will just end right there. Forget about that. So let's say, well, I guess before we draw the bins, what do you want the typical number of shoes to be? Like, typically, how many shoes should people own? So what will our mean? What? 10? Cool, I like that. So the average will be 10. So I'm going to draw my mode. I'm going to put a little line right here at 10. That's like the typical value. So let's say a lot of people own between 0 and 20 shoes. Now, having 20 pairs of shoes isn't like crazy. I always do like a poll when I teach this class. Can everyone just put how many pairs of shoes you think you own in the chat? The most I've ever seen was like 80. And it was a guy. He like was really into sneakers. So usually I always thought that women would have more shoes, but like the record is a man in terms of like students who have asked. Yeah, so a lot of you have like 10-ish. Someone has like 50, too many to count. Okay, so there's some ladies and a couple, and like one gentleman who had like over 30 or 50. So I'm gonna draw the histogram like this. From 20 to 40 it gets less. From 40 to 60 it gets less. I'm gonna leave a gap from 60 to 80, and we're gonna draw like a tiny bin from 80 to 100. Why did I put that gap there? What do you think my reasoning behind that was? Why put the gap? Yeah, to make an outlier. Cool. So right here at 10, we have our typical value. Now, here's the problem with talking about typical. There are a lot of people who are not typical. Does that make sense? Typically, you own 10 shoes, but there's like a bunch of people over here in 20 to 40 and 40 to 60 who are not typical. So one of the drawbacks of talking about the mean is that talking about what's typical doesn't give you all of the information, right? It takes all of its information and says like, well, this is the one number that tells you what's typical. So the spread tells you, well, how far away from typical do people usually get? So you would want to figure out, like, okay, well, up to about here, that's like most of the people. And you would want to say that that distance is your spread. So you'd be like, oh, well, most of the people don't really go past this green line. So typically, they're no more than, say, I drew up to like 50. How far is 10 from 50? I might say like the spread is 40. Why? Because you never get really more than 40 away from the center of 10. Obviously, there are people past there, but a majority of them are in that area. That's what we mean by how far away from typical do people usually go. Now, that doesn't mean that there aren't people who go past that, but most of them don't. Or I have another really good example. This variable will be rent. Oh, sure. Okay. Okay, this will be an interesting example. Let's talk about rent in the Bay Area for apartments. Okay, last time I really looked at the numbers I have was 2018. Guess what the typical rent in 2018 was? Yeah, it's about 2,000. No matter the number of bedrooms. So the mean rent for an apartment in the Bay Area in 2018 was 2,000. Well, yeah, but this is typical. Obviously, Atherton would be an outlier, right? Does that make sense? That's why that's what I was saying earlier. Talking about typical doesn't really give you the whole story. It just says, well, if you look at like what typically happens most often, or the mean or whatever, it's about 2,000. And in the data, oops, wow, that is like a really horrible looking rectangle. Whatever. The most I had in the data at the one I looked at was about 4,000. There aren't too many apartments over 4,000. And from the data that I had, some people paid as little as like $200 for rent for an apartment, probably because they live in a rent controlled thing and they've been living there for like 40 years or something like that. Oops. I'm like having a really hard time like drawing straight lines. I'm like on the struggle bus. Okay, whatever, good enough. And when I looked at the histogram of the data, it was really interesting what I got. It basically looked like this. So what sort of shape did I see in my rent data? How would we describe the shape of this? Oh, yeah. Yeah, good, symmetric. Okay, now what's typical is about $2,000. When I calculated the standard deviation, it was $750. So what that tells you is that yes, typical rent is $2,000, but a lot of people might go up to $750 lower than that. What's 2,000 minus 750? $1,250. Or typically their rent might be up to $750 more dollars than the typical value of 2,000, which would be 2,750. So in other words, anybody between those two numbers would still be considered typical. Does anyone here pay less than $12.50 a month in rent? Does anybody here pay more than $27.50 a month in rent? Okay, there's like one person. But do you see how that one, okay, two people, do you see how most of you are between the $12.50 and the $27.50? This allows you to spread out what we consider to be typical. It's telling you, well, 2,000 is just one number. How far away from that do most people usually get? Well, no more than 750 away from that. So that's what the spread tells you. It allows you to spread out what's still considered typical, as opposed to the single number. Okay? Is that making sense to people? So let me show you how to have Wolfram calculate this. Okay, 1 second while I open up a Wolfram. Wow, my computer is going really slow. Okay, cool. Okay, so I'm gonna change to the Wolfram view. Is that good? Cool? Okay. It's not letting me switch. There we go. Okay, let me change the view. There we go, way better. So, sometimes in the homework, they give you data and you need to do calculations. So, what should our variable be? Let's just, like some numerical variable, what should we look at? We're going to do a mean and a standard deviation. I need to make up numbers, so what should these numbers mean? Someone throw something out there. No, not actual numbers. Like 7 what? Like what will the 7 mean? Like, we had number of siblings, number of shoes, rent. Oh, pets? Okay, I like that. Cool. So pets is going to be the number of pets. So, like, in a homework problem, they might give you a bunch of numbers. And you're going to need to have Wolfram calculate stuff for you. So you give it a name, and then you write equals. And then you put a curly bracket. And then you just type in the numbers separated by commas. So this person had 0 pets, 1 pet, 1 pet, 0 pets, 0 pets. 0 pets. I once had a student who said that it was like they had 83 because their dad was like a parakeet freak. He actually had like one of those big aviaries in like the back of their house, and she was like, yeah, he has like 80 birds last count or something. So anyways, 2 dogs, 6 fish, nothing, and a dog. Okay, so does it make sense if like the problem gives you a bunch of numbers, you need to type it in like this? Say equals, whatever you want to call it. That's up to you. Shift enter and it saves the numbers. Cool so far? Now, let's say you want to know what the mean is. You type in mean and you say mean pets. Boom. It will give you a number. Sometimes if it gives you a fraction, you have to put //n. And it will turn it into a decimal for you. So apparently, what is the typical number of pets here? 7.2. So let's write that down. I'll put it on a little text thing. All right, so since the mean of the data is 7.23, that means that typically the people in the data have 7.2 pets. How well can we see this? Is the font large enough, or should I make it bigger? It's good. Okay, cool. I want to make sure that you can read it. Okay, cool. I also don't want to make it too big because then you can't see everything, right? Okay, guess what the command to find the standard deviation is? It is standard deviation. And then you just put standard deviation of the thing you want to take the standard deviation of. Again, sometimes it will give you like a number with like square roots or a fraction. If you want a decimal, / n. 22. And then we're going to talk about what that means. So, the spread, or since the standard deviation of the data is 22.8. Oh, whoa. Okay, that was weird. Since the standard deviation of the data is 22.8, that means that typical people in the data have somewhere... Okay, this is weird. Like, it keeps... Sorry, it keeps like jumping around. I don't know why. Okay, since the standard deviation of the data is 22.8, that means that typical people in the data have somewhere between... so what we need to do is 7.2 minus 22.8. Somewhere between negative 15 and the other number you need to know is 7.2 plus 22.8. Somewhere between negative 15 and 30 pets. Now, obviously you can't have negative 15 pets, right? So, does it make sense we just disregard that for now? You could put a little note. Obviously, the only valid numbers are between 0 and 30, but whatever. You just put the results that you're getting. And we'll talk more about this later, but it gives you an idea. It spreads out what you think is typical. According to the data, 22 seem to be the typical number of pets. If you take into account the spread, it might get you could say it's somewhere between 0 and 30. Okay, so are we getting this, what the spread does for you? It allows you to make a wider statement about what you're talking about, as opposed to a single number guess. So I'm going to pause. Are there any questions about inputting the data, having it calculate the mean or the standard deviation, or what it means? Yeah, so you start in the middle at the mean, and you go standard deviation minus and standard deviation plus. So let's take a note. So you're going to always be between the mean minus the standard deviation and the mean plus the standard deviation. And we're going to talk about this more, but for now, there's actually like a different rule that you can use, but for now, just we're thinking about it this way. Okay, now this is an important thing to know. You only use the mean and standard deviation if the shape of the distribution is symmetric. So really what I should have done first was looked at the histogram of pets. This is not a symmetric distribution, because does everyone see how the high point is right here? The right tail is really long, the left tail is really short. Okay, so we should not have used the mean and the standard deviation here. But that doesn't matter because we needed it just to explain what they meant anyways. Sure. Okay. So we're going to start learning about other centers and spreads. The mean and the standard deviation are only applicable if the shape is symmetric. So, what do you do if the data is skewed? Okay, so the proper measure, oops, why does it keep on jumping around like this? In that case, the measure is going to be something called the median, and the spread is something called the interquartile range, which is called IQR. We're going to talk about that now. So you use mean and standard deviation if your data is symmetric. If your data is skewed, left or right makes no difference. You're going to use something called the median and the IQR. And we're going to talk about what those are. But this is why it's important to figure out the shape first. If the shape is symmetric, you use certain types of numbers. If the shape is skewed, you use a different set of numbers. Okay. So I'm going to go back to the notes so I can just write about it to tell you what it means. Okay, so let's talk about skewed distributions, i.e. when you're using the median and IQR. Okay, so the median is your measure of center, or what's typical. And the IQR is your measure of spread. Tells you how far away from typical you can normally go. So how do you actually do this? So let's generate some numbers. Let's do number of pets. Can you just put in the chat how many pets you own? Hopefully I'll be able to keep up. 1, 2, 1, 1, 4, 2, 0, 0, 1, 0, 0, 1, 3, 0, 1, 5, 0, 0. And I'll put a 1 for me. Cool. 2. And I think that's enough. No more. Just because I don't want to have like too many numbers. Okay, so the median is the middle number if the numbers are sorted. So the median is the middle of the sorted numbers. So like the median is literally the number in the middle if you were to sort them. So doing this by hand is sort of really annoying because you got to take all these numbers and put them in order. So you start with the zeros. So there are 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. And then you go to the next number. 1, 2, 3, 4, 5, 6, 7 ones. 1, 2, 3, 4, 5, 6, 7. Then you go to the next number. 2. So 1, 2, 3 twos. Oops. I wrote 3. 3 twos. And then you go to the next number. 4. 2 white. 1, 4. Oh, just 1, 4. Cool. And then you go to the next number. Oh, thank you. Rewind. 1, 3. I didn't even notice it. Yeah, and there's the 4 and the single 5. I think I've crossed out everything. Yeah, everything has a little arrow above it. And it's color-coded. It looks cool. It's our happy little, like, rainbow. Okay, so sorting these things is a real pain. Luckily, the computer doesn't mind doing it for you, and it's pretty quick, but it's good to understand what goes on in the background, so we'll do one example. Okay, so you have all your numbers here, and now what you do is you find the number in the middle. So what I like to do is I cross them out from the edges to the middle. So do you see how I crossed out the 2 on the edges, and then I cross out the next 2, and then I cross out the next 2, and then I cross out the next 2, and you keep going until you get to the middle. It's a good idea for you to actually methodically do this because it's like super easy to make a mistake. And also this happens sometimes. You see how I'm left with 2 over? You see how I've crossed them out? If I cross those out, I'm left with nothing. If you're left with 2 numbers like this, you just take their average. So if you have a pair, average them. If you're left with one single number in the middle, that is your median. So the average of 1 and 1 is 1. So the median equals 1. In other words, typically, how many pets do people have? 1. So good with getting the median so far. You line everything up, you have it calculated for you. Or I'm sorry, you line everything up, you cross out until you get to the middle. I'll show you how to have Wolfram do this, but you need to understand what it's doing in the background. I'm just gonna pour myself some tea. Okay, the median is really interesting. So, and I'll show you why. Let's look at this number right here. What was the most number of pets that anyone had? The 10, right? Or 5, my bad, 5. I don't know why the hell I said 10. In our data here, the most pets anybody had was 5. Let's say I go and I change this 5 to 103. Do you see how now there's like one person who's an extreme outlier? Like they had 103 pets. Did that change what the median was at all? Like the fact that this 103, yeah, it does not change it. So the median is really interesting. The median is called robust, since the presence of an outlier does not change the median. The median is literally the number in the middle, right? If you add an outlier out on the edge, it doesn't change what that number in the middle is. Interesting fact, the mean is not robust. It does change if you have an outlier. the mean is not robust since one outlier will change the value of the mean. Oh, okay, what the hell happened here? Sorry, I clicked something and it went crazy. There we go. Let me set this back up. I wanted to put a little dash. There we go. Okay, so the median has this special property. If there's an outlier, it doesn't care, basically. It will stay the same. You could take like the 5 and turn it into 103, nothing changes. But the mean would change if you changed the 5 to like 103 or something like that. And we talked about this before. If you're symmetric, if you're symmetric, what do you usually not have? So this is nice and symmetric. What do you not have usually? Yeah, there's no outliers. But if you're skewed, what do you probably have? Like way over here on this edge, to make it skewed, what's probably out here? Yeah, exactly. And that's why it's important that when you use the median when you're skewed, because skewed distributions usually have outliers. And the median doesn't care about that. So if you have a skewed distribution, you probably have an outlier. The median doesn't get changed by that outlier, which is why we like using it for that. The mean, however, is used when your distribution is symmetric. Symmetric distributions don't have outliers. The mean would be changed if there were outliers. That's why they match up this way. So the big thing here to take away is the median is not affected by the outliers. That's why we use it when the data is skewed. Okay, 1 second. Okay. Can I move away from here? Okay, cool. So let's talk about the IQR now. So let's copy these numbers. We need these numbers again. Wait. That's not what I wanted to do. I want these. This is I love being able to do this. So I can just like copy them. And we'll paste it down here. It's so cool. It's amazing. I'm like never gonna get over this. Okay. So we're gonna get rid of... Yeah, I know. If only you could just like... If I could like swipe them over to you or something. Okay, wait. I got a little too... Okay, whatever. We can see them. Okay, so there's our numbers again. And the median was right here, in between those two ones. I'm going to write an M for the median. Does that make sense? M stands for median. Now the median has some interesting properties. How much of the data is to the right of the median? Like, yeah, exactly. 50% of the data is larger than the median. What percentage is less than the median? Yep. 50% of the data is less than the median, approximately. Okay, here's the funny thing. So the median is a measure of center. It's what's average or typical. Average / typical. People get really interesting when they talk, or say really weird, interesting, sometimes stupid things when they talk about averages, especially the median. So imagine if someone said, "Oh my God, our average students are worse than half of the students." Like, and they're like, "That's unreasonable. Our average students should be not worse than half of the students." I've actually heard people say this. Why is that a stupid thing to say? To say like, "Oh my God, the median was worse than half of the students." Like, why should you not say that? Or why should you not complain about that, I guess is the better question. Someone's like lamenting like the average score for the average GPA like is like lower than half of them. Like, why is that sort of ridiculous? Or I guess I should wonder, does that make sense why that's ridiculous? What do we think? Okay, cool. Okay, cool. So, let's just like come up with a number. So let's just say that, what should we rank people on? Like, what's the variable? Oh yeah, cool. So let's talk about GPA. So let's say we're talking about GPA and we find out that the median GPA is, I don't know, 2.9. And some principal is like, "Oh my God, our students are so shitty. Like 50% of our average students are below, or 50%, let's say this, the president has like this shocked face. Does everyone see like the shocked face? He's like sort of, wait, angry? What does the angry emoji look like? There, that's him, like really angry, saying 50% of our students are below average. And when he says average, he means the median. Why should he not be angry? He's like, "This sucks. My school sucks. 50% of my students are below average." Well, yeah, but is it possible, like, literally the way the median works, can you ever not have 50% of the people below average? No! So when people say, like, "Oh my God, half of them are below average," that's sort of like saying, like, "Oh my God, and the sky is blue." Like, that's just how it's always gonna work. You can't do anything about that. So, like, when you hear people talk about statistics, like, they say sort of shocking things. So hopefully when you leave this class, you'll be able to tell people like, that's just going to happen. There's nothing you can do about that. Right, yeah. So like you get like these weird discussions about like, oh my god, half of our students are below average. And it's like, it's just sort of sad because it's like, apparently, Mr. Principal or whoever you are, you never took a statistics class because you would understand that that's just the reality, right? You could maybe change the average, but you shouldn't be shocked about that. I've actually been in conversations with people and they make statements like that, and I'm like, like you don't understand. It's just how it is, and it's like crazy how people fight you. So I just sort of like want to point this out because I hear it in like actual discussion, and it's infuriating. Okay, so this is always going to happen. The median is in the middle. Half are below, half are above. That's like the idea. That's why we call it the center. Okay, so let's keep going with this. I'm going to erase some stuff. Okay, so we have our 50% there. So let's look at this part right here. The number's less than the median. We had 0, 0, 0, 0, 0, 0, 0, 1, 1, 1. Okay. So does everyone see how I just copied over the numbers that were less than the median? Let's find their median. So I'm going to cross out the edges to the middle. Okay, so what is the median of the lower half? So what is it? Median of the lower half. What's the number? 0. This number is called Q1. The median of the lower half has a name. We call it Q1. It's also known as the first quartile. That's why we call it Q1. That makes sense. The quartile Q, first quartile Q1. The first quartile is the median of that bottom half. Now, what percentage of the data is less than Q1? So in total, what percentage of the data do I have here approximately? I have the 50% and I split it in half. So what percentage is less than Q1? Yes, exactly. Any guesses as to why it's called Q1 now? Yes, because 25% is a quarter, right? The median is sometimes also called Q2 because the median is the 50% mark, right? And how much is 2 quarters? 50 cents. Okay, you can do the same thing with the upper half. If you take the numbers which are larger than the median, you would have 1, 1, 1, 1, 1, 2, 2, 2, 3, 4, and 5. So this is the upper half. So let's take the median of the upper half. So let's do some crossing out. You get that number. So the median of the upper half is 2, right? This number is called Q3. Because Q1 is here at 25%. The median is at 50%. And the next one is at 75%. 3 quarters is 75%. So what this does is it splits your data into 4 equal parts. This is 25%. This is 25%. That's 25%. And then that's 25%. How much longer do we have? What time are we supposed to finish? Okay. I feel like I'm crushing people now. How's everyone feeling? Are you able to absorb more information? Honest opinions. Yeah, I can start. Okay, some people yes, some people no. I think we're gonna end here. Yeah, do you have a question?
Yeah, can I go hang out with my friends?
Beast first.
Please.
No. Okay. So my daughter has to stay home, but you guys, you're done for today. We'll pick up with this tomorrow. We'll review and we'll keep going. So yeah, before you leave.